Alright, the very last part of this quadratics unit is going back to what we did with linears, in a sense. What we've got to be able to do is find that rate of change, which we call slope, and to be able to compare one quadratic function to another. So first thing we're going to talk about is the rate of change, just kind of reviewing what that means. So to find the average rate of change, we're basically finding the slope of the line, so the rise and the run. And remember, we had this formula here. So y is on top, x is on the bottom. And we're going to be given a specific interval. So remember, an interval is just a piece of it. So not the whole picture, but just a piece of the picture. So in this first example, our function is given to us in this table. So across the top, we've got our x values. Across the bottom, we've got our y values. So together, they would make ordered pairs. The directions say to find the average rate of change over the given interval. This time, they're written really different. So what this means, essentially, is you want to find the average rate of change between -2 and 0. So what is my slope between -2 and 0? So again, because your clue is the way it's written. So remember, these are your x values. Any interval you're given for rate of change are your x values. So I need to use the x value of -2 and the x value of 0. So I'm going to go up to my table. There's x is -2. There's x is 0. So together, I have the ordered pairs, -2, 1, and 0, 1. All right, so we want, let's see, we've got an x and a y, x and a y. So in our formula here, our y's are going to go on the top. So we're going to have 1 minus 1 over our x values on bottom. All right, once I do that, guys, I'm not going to do it in my head, and I don't recommend you doing it in your head. Use that calculator, and remember, we're going to go math, fraction. So scroll over to fraction and type that in. Don't guess on it. When you type that in, you're going to get a rate of change of 0. So there is no change from the x value of -2 all the way to the x value of 0. All right, for the next one, this one we want to use the x values -1 and 3. So I'm going to go back to my table, and we've got -1 and we've got 3. So this time we want to use the ordered pairs, -1, 0, and 3, 16. All right, so again, we want our y's on top. So let's see, 16 minus 0 on top. Now, because I started with 16, I have to start with the x value of 3. Then I've got minus, because that's part of my function, my formula, -1. Now, some of you are going to be tempted to go ahead and make the bottom the plus. Don't. Just put in your calculator the exact way you've written it. It'll cut out mistakes, and you're more likely to get the question right. So again, I'm going to go math fraction, type that in, and hit enter. When I do, I get a rate of change or a slope over that specified interval of 4. So as you can kind of compare those two, kind of get thinking in the comparison range, my graph is changing at a faster rate from -1 to 3 as opposed to -2 to 0 because my rate of change was bigger. All right, for the next one, this time you're given a graph. So first thing, let me explain to you what this part means. Remember when you're given f of x. F of x is just the same thing as y. But in this case, it wants the y value of b minus the y value of a. So it's just a fancy way of saying y is on top, x is on bottom. All right, for this example, we want their average rate of change from x equals -4 to x equals 1. So from my graph, I'm going to use x value of -4, which is here, and x value of 1, which is here. So now what I do to find my y values, I go to those x's and I go either up or down to where my graph is. So if I start with the 1 over here, I'm going to go down to my graph to that point there. So that point would be 1, negative 5. Point over here for my negative 4 is right there. It's where it touches my graph at. And that is the point negative 4, 0. So now I've got my x's and my y's. I'm going to go ahead and put it in my formula. So 0 minus negative 5 over negative 4 minus 1. And again, I'm going to go math fraction, type that in exactly as I've written it, and hit enter. When I do that, I get negative 1. So to go from negative 4 all the way to positive 1, my graph is changing at a rate of negative 1. That's what that slope means. Okay. Next one. Find the average rate of change for the following equation. F of x equals negative 2x squared plus 4x minus 6. And then I've got x equals 0 and x equals negative 2. For these, you've got options. The first option is to plug x in. Plug each x in. That will give you y. Then together, you've got your ordered pairs. All right, your second option is to go to y equals in your calculator, type that function in, and then go to the table. And you're looking specifically at x equals 0 and x equals negative 2. There you can find those y values. I'm going to use the table because remember that EOC is timed and you don't want to waste a lot of time on unnecessary steps when there's an easier way to do it. So what I want you to do, pause it, and I want you to type in that function. Go to y equals, type it in. When you do that, hit play and go from there. Alright, so you should be looking at the table in your calculator. And when I find my x value of 0, so remember you've got x's and you've got y's. When I find the x value of 0, the point next to it is negative 2. So that's my first order pair, 0, negative 2. When I go to the x value of negative 2, my y value shows me negative 18. So my second order pair will be negative 2, negative 18. So now I'm going to put that in my slope formula. Y is on top, x is on bottom. Again, I'm going to go to math fraction, type that in, and I get a rate of change of 8. Okay, same thing with this one. You should already have y equals in your calculator, so now it's just a matter of looking for these specific x values. So where x is 5, that gives me the ordered pair 5, negative 36. Where x is negative 3, that also gives me negative 36. So remember, if you're kind of confused at that part, why is it giving me the same value? Remember, with that quadratic, it's going to, at that vertex, it turns and starts going the same way again. So that's where those ordered pairs start repeating. So I'm going to have negative 36 on top minus negative 36 over 5 minus negative 3. When I type that into my calculator, I get a rate of change of 0. And remember, when you're typing it in, this first one is a minus sign. This one is a negative sign. Remember, that calculator is going to not recognize the difference between the two. Alright, so now we're going to switch gears and we're going to go to our comparing. So remember, when we compared linear functions, we were able to compare them from their equation, so the algebraic. We were able to compare them verbally, where we had to make our own equation, graphically, which is pretty self-explanatory from a graph, and from a table, which is numerically. So what you've got to be able to do for that test is, given an algebraic version of a function, be able to compare its characteristics to the graph of a different function. So for the very first example, you're asked to compare the vertex of each quadratic function. And if you look, you've got 3. So you've got f of x, g of x. So those two are going to be the algebraic versions. And then you've got the third one of h of x. So let's start with the very first one. So f of x. F of x is already in vertex form. So finding the vertex should be pretty simple. So remember, from vertex form, you look for h and you look for k. The thing to remember about that is, remember when we do h, we do the opposite. So my vertex for the first one is going to be at 3, 4. Okay, now I'm going to go ahead and skip over to my h of x, my graph. Vertex is that low point. So here's my low point right here. And that's going to be, I'm over 1, 2, 3, 4, up 1, 2, 3. So that one has a vertex at 4, 3. Okay, now remember, we technically haven't answered the question yet. We technically haven't compared them. All we've done so far is find them. Alright, so now I'm going to do my standard form equation. And again, with this one, you can type it into that calculator and y equals, look at that table. You could find it by finding h, plugging it back in and finding it k. You could type it in that calculator and look at the graph of it. So you've got lots and lots of options. Pick whichever one you're most comfortable with and go with that one. When I did this, I actually typed it into the calculator and looked at my table, and I ended up with the vertex -4, -3. So what I want you to do now is I want you to pause it, pick whichever method you're going to use, and I want you to practice finding the vertex for g of x, whichever method you do. Okay, so now we have all 3 vertex, whatever. So now I actually have to answer my question. When I go to compare these things, I want to think about where they are on that graph. So I'm going to borrow h of x's graph over here for just a second. So the vertex of h of x is located here at 4, 3. My f of x has a vertex at 3, 4. So that would be here. So that would look something like that. And that would be f of x. Alright. The g of x is -4, -3. So that would be way over here. So to compare them, I could say something like f of x has the highest vertex. Oops. I could say something like g of x has the lowest vertex. Either way you answer it, you want to show that you've actually looked at all 3 of them and compared all 3 of them. Another thing you could even put is f of x, g of x, and h of x all have minimums. So that could be a comparison as well. If you're not sure whether they're a min or a max, remember you can always type that in a calculator and look at the graph. And these calculators are good enough to where you could even type in f of x and g of x and look at the pictures of both of them on one and then compare that to the graph that you have with h of x. So there's lots of ways to go around it. Just make sure, though, in your answers, you are actually comparing each thing to each other. Show that comparison. All right, for the next example, we're told to compare the rate of change over the interval from 0 to 2. So this time, we just want to look at the rate of change. And if you remember from linears, we're going to ignore negatives. Remember, it just wants to know which one is changing at a faster pace. So that negative just means, okay, I'm going up or I'm going down. It doesn't really tell me how fast I'm changing. So with this one, I need the x values 0 and 2. So for my graph, I'm going to get 0 right there, so 0, 0. And then I need 2. So over 2, and we're going to go all the way up to this one. So that would be 2, 4, 6, 8. So there's my two ordered pairs. So I'm going to put those in y minus y, x minus x. And when I type that into my calculator into math equals, I get a rate of change of 4. Okay? So I've got one, now I've got to find the other. And I'm going to use the same interval so that they're easily compared. Because if you've noticed, for quadratics, you don't have that constant rate of change that you do when you have a linear function. A quadratic rate of change is variable, meaning it's going to change from point to point to point. So again, I'm going to use x values of 0, x value of 2, and I've got order pair 0, 0, and 2, 8, which for some of you at this point, you're looking at that going, okay, those are the same order pairs. If you're not seeing that yet, remember, put it in, y's on top, x is on bottom, put that in your calculator, and you'll see you are going to get 4. So when I compare those two, I would say something like the rate of change is the same for both functions. You could be more specific and say f of x and g of x have the same function, same rate of change over the specified interval. There's lots of different ways just to say basically they're the same. But the more key vocab that you use, the better your answer sounds and the more points you're going to get on that EOC. So keep that in mind. Alright, for the last example, this one is actually comparing a quadratic to a linear function. So this is something that we haven't really done yet. So if you look at the problem, it says Jim is kicking a ball into the air. The scenario can be represented by this equation. So here's Jim's equation. There's Jim. At the same time, Chuck is rolling a ball down a ramp that is 18 feet high. The equation to represent this is g of t equals negative 2t plus 18. Alright, so first thing I would make a note of is Jim is dealing with a quadratic. Old Chuck is dealing with a linear function. So no, that's not a typo, that's actually a linear function. And you'll notice the difference between the two is one has the exponent, one does not. So the first question that we're going to be asked is whose ball will hit the ground first? Okay, so think back to quadratics. When we first started looking at quadratics, we started solving these things. Then we were given word problems that said, how long will it take the ball to come back down to the ground? How long will it take the guy diving off a cliff to hit the water? So with this first question, it means solve it. Hit the ground is your key words. Ground means solve it. So how long will it take? That's what we're solving for essentially. So when I solve for Jim, Jim's got the quadratic. So I'm going to go back and I'm going to use my quadratic formula. So what I'm going to do is I'm going to go to the next page so I have plenty of room. There's plenty of room at the bottom of your paper. So you can just scroll down there, look down at the bottom of your paper, and you can start doing your work there. So Jim's equation, I'm also going to set it equal to 0, was negative 16t squared plus 124t. So go back to your quadratic formula. A is negative 16, B is 124, C is 0. So I'm going to put that in my formula. Opposite B, plus or minus 124 squared, minus 4 times A, times C, all over 2 times A. Alright, then I'm going to go to math fraction in my calculator, plug that in, and I'm going to get my two solutions. So pause it, type that in, and get your two answers. All right, my first answer for Jim was 0. My second answer was 31/4, which I turned into the decimal 7.75. So with my two answers, one of them doesn't make sense. The 0 here makes no sense. So far, Jim's kicking that ball, and it took 7.75 seconds to return to the ground. Okay, so I've got my one figured out. Now I've actually got to look at Chuck's to be able to compare it. So we're going to look at Chuck right here. All right, Chuck's equation, remember, was a linear equation. 0 equals negative 2t plus 18. So remember, I'm setting it equal to 0 again because that's when it comes back to the ground. So essentially, it's an intercept. So to solve this one, we'll move 18 over. Then I'm going to divide by negative 2. And it took Chuck 9 seconds to roll that ball down. So if I look at my question again for A, it said whose ball will hit the ground first. So with this, you got to think about what time means. It took Jim 7.75 seconds. It took Chuck 9 seconds. So if I'm comparing my times, Jim's ball is going to hit the ground first. It's going to hit the ground about a second and a half earlier before Chuck's. So to answer that question, I would say Jim's ball will hit first. And because these are my notes and I want to make my notes somewhat usable, 7.5 seconds is faster than 9 seconds. Okay, so there's our first comparison. Our second comparison says to compare the rate of change over the interval 2, 6. So again, we've got those options. We can take 2, 6, plug each of them in, solve them, get our y value, and do y minus y over x minus x. But remember, because the test is timed, you don't want to waste precious seconds when there's a faster way to do it. So what I would do is I would take Jim's equation, type it into y equals, and look at my table. Then I would take Chuck's equation, type it into y equals, hit my table, and look at my x values that way. So whatever method you pick, I want you to pause it right here, find your ordered pairs, and go ahead and find your rate of change. Then press play and check. All right, so with Jim, I'll do Jim first. His ordered pairs turned out to be 2, 184 and 6, 168. So when I put that into y minus y, x minus x, I'm going to do that, and that gives me negative 4. So some of you might be wondering, okay, why is it negative? Well, if you think about what they're doing, he's rolling a ball, he's kicking the ball into the air. So it's going to go up, but then it's got to come back down. So that down part is where that negative slope comes from. All right, for Chuck, his ordered pairs were 214 and 6, 6. All right, so we're going to have y's over x's, and we get negative 2 as a rate of change. So remember, when you compare rate of change, ignore those negatives. So really, I'm looking at 4 versus 2. Which one is changing at a faster rate? And that's going to be Jim's. Jim's is changing at that faster rate. So I would answer that question by saying Jim has a greater rate of change.